Welcome to EPG Pathshala. Dear students, today's module is about the impacts of large-scale exploitation of solar energy and wind energy. The utilization of all the energy sources has some impact on our environment. The degree of impact mainly depends on factors like techniques involved, climatic factors, population, geographic location, etc. Not only the fossil fuel consumption has the negative impacts on environment, even the renewable energy sources also affect the earth. Renewables are now cost competitive with this fossil fuel in many markets and are established around the world as mainstream sources of energy. So, the understanding of the impacts caused by different renewable energy sources help to reduce it with the help of efficient technologies. So, in this module, we are going to discuss about what are the impacts of solar energy and what are the impacts of wind energy exploitation. And we will also see some of the solutions to reduce these negative impacts related with the solar energy and wind energy harness. Let's start with solar energy. Solar energy refers to the energy derived actively or passively from the sun. The total solar energy absorbed by Earth's atmosphere, ocean and land masses is approximately 38,50,000 exajoules per year, with a potential of supplying 1,575 to 49,837 exajoules, which far exceeds the global requirement. This large potential makes it a highly appealing source of electricity. Solar techniques are characterized as either active or passive depending on how they capture, convert and enable solar energy to be utilized. The active solar techniques include use of photovoltaics, concentrated solar power, solar thermal collectors, pumps and fans to convert sunlight into useful outputs. While the passive solar techniques include selection of materials with favorable thermal properties or positioning and designing structure that naturally circulate air or use heat energy. Solar power is the conversion of sunlight into electricity either directly using PVs, photovoltaics, or indirectly using generally the CSP, that is concentrated solar power. These technologies contribute to sustainability of our activities by providing several environmental advantages like the reduction of carbon dioxide and other greenhouse gas emissions or the emission of waste products during their operation. The growth of solar power. The construction of solar photovoltaics globally has grown at an extraordinary rate, becoming a mainstream electricity source. This rise in solar photovoltaics is driven by government and businesses chasing targets for low carbon energy. China now leads the cumulative capacities, followed by Germany, Japan, USA and Italy. The total installed capacity at the end of 2015 globally amount to 27.1 gigawatt. The generation costs are becoming comparable to retail electricity prices, and in some places solar photovoltaics may become competitive to the average wholesale electricity prices. The International Energy Agency in 2014 projected that by 2050 solar power is expected to become the world's largest source of electricity, with solar photovoltaics and concentrated solar power contributing 16 and 11%. Solar resources in India. The country's solar installed capacity reached 20 gigawatt in February 2018. India ranked number 1 in terms of solar electricity production per watt installed, with an installation of 1700 to 1900 kilowatt hours per kilowatt peak. With about 300 clear sunny days in a year, India's theoretically calculated solar energy incidence on its land area alone is about 5000 trillion kilowatt hour per year. The daily average solar power plant generation capacity over India is 0.2 kilowatt hour per meter square of used land area. The Indian government has also shown its support through various plans and missions which aimed at expanding the solar capacity. And the solar products have increasingly helped to meet the rural demands of energy. Now, we will see the impacts of solar energy use in detail. The potential environmental impacts associated with solar power are land use and habitat loss, microclimate modification, water use, discharge of hazardous material, emissions and ecosystem flora and faunal effect. This can be vary greatly depending on the technology and the scale used. There are also several social and economic impacts. So, we will see the land use and microclimate modification in detail. The solar facilities require large land area for their establishment for the solar radiation collection, rendering them unavailable for agriculture and disturbing already existing land uses like grazing, pasture. They can impact the use of nearby areas such as forest area, sensitive zones or ecosystems. It is estimated that about 3.5 to 10 and 4 to 16.5 acres of land area will be required to produce 1 megawatt of power in photovoltaic and concentrating solar thermal power respectively. The land area required varies depending on technology, site topography and the intensity of solar energy. Land impacts from solar systems can be minimized by carefully siting them at lower quality locations such as waste or degraded lands, abandoned mining land, etc. In environmental terms, rooftop solar system is the greenest approach, but it is more complex and costly. Solar panels established on ground causes shading and changes to wind flow, thus altering temperature. This can also impact solar moisture over the land. Land clearing can result in soil compaction, alteration of drainage channels and increased runoff and erosion. Several studies demonstrate how solar farms alter the way incoming energy is reflected back or absorbed, stored and re-radiated due to changes in albedo, vegetation and structure of the terrain by the photovoltaic units. So, one alternative location for solar power plants would be the use of water surface area available on canals and other water bodies, which can also provide water needed for cleaning of panels. The roads adjacent to highways and railways may be utilized. This practice would also protect the highways from damage from the rain and intense summer heat and offer additional comfort to the commuters. Keeping this in view, the state government launched rooftop solar power generation scheme in Gandhinagar, Gujarat. Under this, solar panels are proposed to be put on state government and private buildings. Also, there are examples where solar panels were to be placed on the Narmada Canal branches under the 1 megawatt canal solar power project, with the added advantage that 90,000 liters of water would be saved from evaporation per year from the Narmada river. Recently, the concept of solar power tree with rotatable mechanism enables the leaf-shaped solar panels to keep facing the sun throughout the day, enabling 10 to 15% more power generation over the fixed type, along with the allowing cultivation practices without any hindrance. It uses only 4 square feet for 5 kilowatt tree compared to 400 square feet for normal layout. Some studies are aimed at the possibility of growing plants along with the solar panels with suitable designs or the density or the height. In North Carolina, the growth of crops that cannot survive in the direct sunlight are observed under solar panel arrays installed at some height. It was noted that lettuce, which cannot grow in open sunlight, is successfully cultivated in the land under these solar panels. Such studies help in reducing the food versus energy debate from the solar farms. The second impact is on the water use. The manufacturing of PV components requires some water for periodic cleaning or reflective surface. Other than this, concentrating solar thermal plants require water for cooling. The plants using wet recirculating technology with cooling towers withdraw between 600 and 650 gallons of water per megawatt hour of electricity produced. The plant design, location and types of cooling system affect the quantity of water used. Those systems which do not require water may be a better option in the water scarce area. The third impact is discharge of hazardous material. The solar cell manufacturing process includes a number of hazardous materials. The amount and type of chemicals used depends on the type and size of the system. Inhalation of silicon dust is also a matter of great seriousness when considering the risk faced by the workers in solar field. The toxic compounds like gallium arsenide, copper indium gallium diselenide and cadmium telluride are found in higher quantity in the thin film photovoltaic cells than those used in the traditional solar cells. In addition, the short lifespan of the batteries used in the stand-alone solar systems add to the environmental risk due to their heavy metal content and disposal problems. The improper handling and disposal of these materials could pose serious environmental or public health threats. Another impact is the emission. Though there are no emissions during solar power generation, there are emissions associated with other activities like transportation, manufacturing, installation, maintenance and dismantlement. The estimates of life cycle emissions for photovoltaic cells and the combined solar power systems are between 0.07 to 0.18 and 0.08 to 0.2 pounds of carbon dioxide equivalent per kilowatt hour. These are far lesser than the life cycle emission rates from the natural gas or coal. Another impact is on the ecosystem, flora and fauna. The establishment of solar energy project would involve vegetation and topsoil removal for construction of plant, access, roads, transmission lines, etc. that can lead to loss of wildlife habitat, reduction in the plant diversity and potential for increased erosion. For example, flying insects can be burned when flying close to the reflectors area. So, appropriate care should be taken to ensure that such schemes are not installed in a ecologically sensitive area or in areas of natural beauty. And if we take that precaution, it can avoid damages to flora and fauna. There are some positive impacts like societal impacts by the solar energy. The solar power is a boon in areas which are still not in the reach of electricity and which can be seen in several developing countries. The solar electricity has emerged as a key alternative to grid-based rural electrification. Studies in Kenya, India and Bangladesh reveal solar photovoltaics play a more substantial role in supporting the use of electric light for key social activities. India currently has around 1.2 million solar home lighting systems and more than 3.2 million solar lanterns sold or distributed. In agriculture sector, the solar systems also has its importance. The solar photovoltaic water pumping systems are used for irrigation and drinking water. Solar dryers are used to dry harvest before storage. So, the direct economic impacts would include the creation of new jobs for construction workers and the associated income and taxes generated by the solar project. Till now, we have seen the impacts of solar energy. Now, we are moving to the wind energy. Wind energy is one of the cleanest and most sustainable ways to generate electricity. It helps in the harnessing of power from the natural flow of wind as it produces no toxic pollution nor greenhouse gas emission. Wind is abundant, inexhaustible and affordable resource, making it a viable and large-scale alternate to fossil fuel. Several wind turbines are connected to a common electric power transmission network constitute a wind farm. So, as a general rule, the wind generators require wind speed of 16 km per hour or greater for its economic production. They can be of different types: onshore grid connected wind turbine systems, offshore wind turbine systems, small wind and hybrid energy decentralized systems. In recent years, onshore wind energy has become competitive with other energy sources and also found cheaper than these fossil fuel derived energy in several places. The world's largest onshore farm is located in Germany. Offshore wind, though, is steadier and stronger than on land, but construction and maintenance costs are considerably higher. Despite its vast potential, there are a variety of environmental impacts associated with wind power generation that could be recognized and mitigated. The global cumulative installed capacity of the wind power increased from 17 to 432 gigawatt during 2000 to 2015, and China accounted for 33.6% of the total installed wind power, followed by US, and India's position is fourth with 5.8%. MNRE, the Ministry of New and Renewable Energy, set up initial wind farms at Maharashtra, at Ratnagiri, Gujarat and Tamil Nadu. As of 31st August 2016, the installed capacity of wind power in India was 27 gigawatt. The potential for wind resources in India is estimated in the range of 49,130 to 2000 megawatt by National Institute of Wind Energy. Now, we will see the impacts of wind energy operation and use. The typical activities during the wind energy facility operation phase include turbine operation, power generation and associated maintenance activities that would require vehicular access and heavy equipment operation when large components are being replaced. It has impact on ecosystem. The unfavorable ecological effects that occur during the operation of wind farm from the disturbances due to turbine noise and human activity, particularly in the construction phase. Site maintenance, exposure of biota to contaminants, mortality of birds and bats that collide with the turbines and meteorological towers. During the operation of a wind facility, the plant and animal habitat are affected by habitat fragmentation due to the presence of turbines, support facilities and access roads. The development of such big farms for energy production will naturally lead to increased access roads, traffic of vehicles and increased frequency of movement of people in those areas. And in turn, it impacts ecological resources in the surrounding areas through introduction and spread of invasive vegetation, habitat fragmentation, biota disturbances and increased potential for fires. The wind power harnessing has impact on the soil. Building roads in forest can cause linear fragmentation, while in hilly areas cause erosion and landslides. Lack of proper guidance and overview to ensure the existing fragile areas are maintained or looked after can also lead to problem. The various factors that make coastal locations ideal for wind farm also hinder its development due to people resistance. In a study on the Nalakonda wind farm in Andhra, the construction of roads led to landslides, erosion and silting of water bodies. The adoption of remedial or control measures could have prevented several problems like retaining walls on the roadsides on hilly slopes to prevent the soil erosion, replanting trees or revegetation around the turbines, creating a diagonal or steep slopes on hillsides would have made it possible for the goats and sheep to once again graze on that hills. Another impact is on the land use. The land use varies depending on the site, as turbines placed in flat areas use more land than in hilly areas. Usually, it is placed between 5 to 10 rotor diameter apart, and the turbines do not occupy all of the land, allowing simultaneous activities like grazing farming. A study by the United States National Renewable Energy Laboratory on the wind farms over 9 years found that only 0.43% was permanently disturbed by installations. Co-location of other forms of energy development could include directionally drill oil and gas wells, underground mining and geothermal or solar energy development. Recreation activities are also possible, but activities centered on solitude and scenic beauty will be affected. The military operations and aviation could be affected by radar interference associated with the operating turbines, and low altitude activities could be affected by the presence of turbine over 200 feet high. The turbines and blades being bigger, offshore wind facilities require larger space than the land-based wind turbines. Also, offshore installations may prove to be a problem to other ocean activities like fishing, oil and gas extraction and navigation depending on their location. These turbines are less obtrusive than on land, as their apparent size and noise is mitigated by the distance. The water has less surface roughness than land. The average wind speed is usually higher over the open water. So, employing best practices in planning and siting can help minimize potential land use impacts of offshore and land-based wind projects. It also has impact on microclimate modification. Some effects on temperature, humidity level due to turbulence, higher concentrations of carbon dioxide, methane and nitrous oxide is observed in wind farms. The meteorological conditions such as rainfall also affected due to turbulence from spinning wind turbine rotors that increase vertical mixing of heat and water vapor that affects meteorological parameters. Wind farms can lead to a slight warming at night and slight cooling during the daytime. The use of most efficient rotors or establishment of farms in areas of more natural turbulence can mitigate these aspects. It has impact on the wildlife and habitat. The consideration of sensitive ecosystems, threatened species and migratory channels and paths during construction and siting of turbines help reduction in the impact on the wildlife. But the major impact is the bird mortality. It depends on the location, construction and height of turbines. Studies on wildlife and bird deaths in India revealed that birds like Asian palm civet, swallows and martins, black kites are affected and maximum collision risk in winter. The displacement of birds both during the construction and operational phases of windmills due to visual intrusion and noise, vibration impacts and vehicle and personal movements related to site maintenance amount to this habitat loss. The changes in air pressure due to spinning turbines and habitat destruction as well as collision with turbine blades found as reasons for bird and bat deaths according to several observations. So, suitable adjustment in turbine speeds can reduce bird deaths without affecting the power generation. The marine wildlife and fish population is also affected due to offshore wind farm. The increase in fish population is reported by some studies with wind turbines acting as artificial reefs. The proper research and monitoring system help to identify the site-to-site impacts from these offshore wind facilities. The major impact of the wind power harnessing is noise pollution. Wind turbines generate sound depending on design and rotation speed due to movement of turbine blades through the air. There is also mechanical sound generated by the wind turbine itself. The people staying closer to wind turbines are more likely to be affected by this noise. The magnitude of the noise impact depends on distance of human settlement from the windmill, topography, water bodies, weather, etc. The sound and vibration issues are not found to adversely impact public health. In India, the Ministry of Environment and Forestry guidelines recommend that wind farms should not be set up closer than 300 meters from habitation, but it is not mandatory. There are no requirements to monitor noise from these wind turbines. So, it has an effect on the human health. Anyone looking at an operational wind turbine or a massive wind farm would have a particular perception about the view. For any number of reasons, it can be positive or it can be negative. Observers says that wind turbine could not affect their health, but they would be wrong, because according to World Health Organization, health is defined as a state of complete physical, mental and social well-being and not merely the absence of disease or infirmity. From a practical viewpoint, the operation of a wind turbine does not directly impact human health, but it is true that factors such as stress and loss of sleep contribute to health problems from some residents living close to these installations. Stress can be generated by frustrated residents that have to put up with this noise pollution and adverse visual impact and loss of land value. It also results in loss of sleep in people living nearby these wind farms. And also, this wind turbine noise annoyance and unpleasant sounds include rhythmic modulation of low frequency noise, and increasing sound pressure levels results in increased level of annoyance. And these annoyances are reported when the turbines were visible and when the observer reported a negative impact on the surrounding landscape. Even the persons living 10 miles away of these wind turbines also reported this complaint. Maggie noted that Nina Pierpont is reporting that the people who live within 2 kilometers of wind turbines are reported sickness that can be traced to the presence of this low frequency noise and infrasound, that is sound less than 20 hertz, appear to be the problem. And this problem, the problem that Pierpont and the others have reported is known as wind turbine syndrome, which is the disruption or abnormal stimulation of the inner ears vestibular system that caused by turbine infrasound and low frequency noise. And the symptoms of these wind turbine syndromes are sleep problems, headaches, dizziness, exhaustion, anxiety, anger, irritability and depression, and also the problems with concentration and the learning. It also has tinnitus, that is ringing in the ears. So, along with the turbine noise annoyance generated by the mechanical and aerodynamic factors, the feeling of resentment, displeasure, discomfort, dissatisfaction or offense that occurs when noise interferes with someone's thoughts, feeling or daily activities. There have been complaints about rhythmic light flicker causing intermittent shadows, that is known as shadow flicker or flickering shadows. Wind turbine noise generation is also related to high levels of low frequency noise over the years of exposure, and this is known as vibroacoustic disease, that is VAD. This disease or syndrome is commonly classified as mild, moderate or severe. Mild, if it is for 1 to 4 years, it includes the symptoms like slight mood swings, indigestion, heartburn, mouth or throat infection, bronchitis. While moderate, if it is exposed to 4 to 10 years, then chest pain, definite mood swings, back pain, fatigue, skin infection, inflammation of the stomach lining, pain and blood in the urine, conjunctivitis, allergies, other result. Severe one, if it is exposed more than 10 years, then psychiatric disturbances, hemorrhages in nasal, digestive, conjunctiva mucosa, varicose veins, hemorrhoids, duodenal ulcers, spastic colitis, decrease in visual activities, headache, joint pain, muscular pain, neurological disturbances. Apart from this human health, it can also has impact on the aesthetics. So, careful siting of wind farm is a necessity. Some people consider location of wind turbines near culturally and historically important place a threat for sustainability. So, modification of scenic quality, particularly in areas of cultural value or traditional value to some people or low income populations are considered environmental injustice. Large wind turbines and associated facilities affect some cultural resources such as landscapes or historic trails. In landscapes, the wind energy development projects would be highly visible in rural or natural landscapes, many of which have few other comparable structures. So, visual evidence of wind turbines cannot easily be avoided, reduced or concealed due to their size and exposed location. Therefore, effective mitigation is limited. Additional issues of concern are shadow flicker, that is straw-like effects from flickering shadows cast by the moving rotor. Blade glint from the sun reflecting of moving blades, visual contrast from support facilities and light pollution from the lighting on facilities and towers. So, additional visual impacts from vehicular traffic occur during maintenance and as towers and rotors are upgraded or replaced. When replacing turbines or other components, the opportunity and pressures to break uniformity of spacing between turbines and uniformity of size, shape and color among facility components increase the visual contrast and visual clutter. Infrequent outages, disassembly and repair of equipment occur, remove the appearance of idle or missing rotor. Headless towers and lower towers as well as negative visual perceptions of lost benefits and the barnyards are other reasons for this reduction in the aesthetic view. The next is the impact on the water resource. It has impact on water use and quality and the flow systems during operation phase and is limited to possible degradation of water quality resulting from vehicular traffic and pesticide application if we are not conducting that properly. There are no direct air emissions from operating wind turbine. The production, transportation, on-site construction, operation and maintenance and dismantlement create certain amount of greenhouse gas emission. The minor volatile organic compound emissions are possible during routine maintenance activities of applying lubricants, cooling fluids and greases. The minor amounts of carbon monoxide and nitrogen oxides would be produced during periodic operation of diesel emergency generator as part of preventative maintenance. The vehicular traffic continue to produce small amount of dust and tailpipe emissions during the operation phase. These emissions not likely exceed air quality standards or have impact on climate change. Life cycle emission estimates from the wind turbines range from 0.02 to 0.04 pounds of carbon dioxide equivalent kilowatt per hour. The construction activities generates lot of solid waste. Though these solid waste consists of plastic, packaging material, containers, waste from the assembling of equipments, there might be some amount of solvents and paints among the industrial waste. These hazardous materials stored on site for vehicle and equipment maintenance include the petroleum fluids, coolants, battery electrolytes. The oil, transmission fluids and dielectric fluids brought to the site to fill turbine components and other large electrical devices. The compressed gas is also used for welding, cutting, brazing, etc. So, improper handling of these wastes can lead to them being released into the environment, if not within the site, then in some off-site locations. Industrial and sanitary wastes are generated during routine operations, and these wastes are typically put in containers, characterized and labeled, possibly stored briefly and transported to an appropriate permitted off-site disposal facility. Similarly to the solar power, wind power also has some socio-economic impact, which are mainly the positive impacts. The direct impacts would include the creation of approximately 1 new job for every 3 megawatts of installed capacity for operation and maintenance of wind energy development project, as well as associated income and taxes paid. The creation of new employment opportunities and improved businesses of supply of relevant material for the project, as well as expanded workforce. It will lead to economic development and associated income in that area. The property values in that area may be affected positively due to more employment opportunities and availability of green energy. But it can negatively affect due to associated or perceived impacts from proximity to wind farms and environmental effects. So, to conclude, the large scale exploitation of solar energy and wind energy had ecological, social, economical impacts. The reduction in those negative impacts of solar energy and wind energy may help those energy sources to be more commercially feasible. We have seen that the potential environmental impact associated with solar power are land use and habitat loss, microclimate modification, water use, discharge of hazardous material, emissions and effect on ecosystem flora and fauna. We have also seen the environmental impact associated with the wind power, that are impacts on an ecosystem, land use, microclimate modification, effect on wildlife and habitat, and especially the noise pollution with respect to human health, including sleeping problems, headaches, dizziness, exhaustion, anxiety, problems in concentration and learning, and ringing in the ears. And we have also seen some of the solutions by which we can reduce these negative impacts while harnessing the solar energy and wind energy for meeting the energy demands. Thank you.